Hi. In my haste last time, and because I was enjoying story time myself, I guess, uh, I didn't quite finish that last problem. So recall we said this was the impulse response, and then you had, uh, secondly, we had a unit impulse at time zero and another one with double. This was one, that was two. So those were our two inputs. All right. So what would have been the response to that? Okay, the first impulse happens at time zero, so that causes one full impulse response. Every impulse gets an impulse response. That's simple. All right, at time one, we have an impulse of double the strength, so it means we get this times two. All right, so this went up to height two, so if I double it, it goes to height four. So here's this picture. All right, so what's the response going to be? All right, every impulse gets an impulse response. So it'll be this, and then this starts going down while this one's coming up. If you add them together, it'll be dot, dot, dot going up to here. At time equal 2, you have that's at 4, that's at 0. So that's where they are. And then this one just makes its way back down. So the total response looks like this. And then once all the impulse responses are done, response is done. Each impulse in sequence causes another impulse response. All right, so let's start applying this in a few places. And so here's going to be sort of the same problem. Okay, we're just building up this. Instead, we have an impulse response that for every impulse we get, when it happens, it jumps up, and this is to have height 1. Okay, and here are the impulses we're going to have. Now keep in mind, for an impulse, uh, hard to see. Darken that up a little bit. Hopefully it's easier to see for you. We have an impulse that happens at time 0. When this argument equals 0, well, that's when t equals 0. We have an impulse at time 0. Then we have a double impulse. When is this 0? When t equals 1. So this is the equation for that impulse sequence we had in the previous problem. All right, if we apply common sense, I'm going to get one of these for this and one of these for that, except because of that 2, it'll be doubled. So common sense says, here we are at time 0, here's an impulse response, and starting at time 1, here's another one that's happening, except it goes up 1, 2. Now it's going to be, keep in mind, this one started at 0, so it's still going on while this next impulse happens. So they add up. If we add these up in just a common sense way, we go boom, boom, up to here, over to here, then this one drops, we drop over, we come the rest of the way down. That's what we have here. Just adding these up, there's the response. Let's look at it mathematically, all right? So we're going to let the integral do it. Same problem, all right? At t equals 0, right, we have I of t minus tau. Well, regular t is now 0, all right? So we go in here and we replace, for the input, it becomes 0 minus tau. So we replace this t with 0 minus tau, and this t with 0 minus tau. Okay? So we do that substitution, and what does that show? All right. Well, what does it take to make this get a 0 out of this? We have to put a minus 1 in here, so boom. So here's tau minus 1. That's where this one is at the moment. Working, sliding over. And this one, well, if t is 0, we have a 0, so boom, that's happening. So this first impulse starts exciting the impulse response. All right, so here's the equation. Here's the I of 0 minus tau, and we multiply it by s of tau. And the only place, there's nothing out here, and there's no inputs out here. So we multiply this times this. All we get is what's happening right here. That's all there is. So we're just going to sift out the value of the impulse response at time equals 0. That's just 1. So there we have it. And that agrees with what we had. We go whoop, up. Now let's go to time equal to 1/2. So right here, at 1/2, we see here's where we are. So we're predicting an answer of 1. We go to the input 1/2 minus tau. We insert this into the previous equations. So t is replaced with this. This is 0 when tau equals 1/2. Okay. And this is now the second one. We do the same thing, but this is 0 when tau equals minus 1/2. All right. So here's a picture of our situation. Here's the impulse response. The first input is 1/2 of a second into exciting this thing. And this thing has another 1/2 second before it rams into this. And it actually happens. It obviously happens at time equal to 1. So we're not there yet. That's what this is showing. We take that input, flip it, and now we're sliding it through. So it's just not in there yet. Again, now we take the integral. I didn't want to write all this stuff down, so I just put a dot there. But if you multiply the input times the impulse response, here's the only intersection here. This is an impulse, and when you integrate it, all you get is the sifting function. So it's the impulse response at time equal to 1/2, which is a 1. It's a 1. It agrees with what we have. All right. So now we're going to move to 3/2. 1.5 seconds. We're predicting an answer of 3 from our common sense thing. All right. So when you do these, I strongly recommend draw pictures. All this flipping and sliding can get a little confusing. If you draw a picture, you can organize your thoughts. And we're going to practice a bunch of these, but I draw pictures. I do this. All right. So at time 1.5 or 3/2, we stick 1.5 minus tau or 3/2 minus tau, whichever one turns you on, into, here's the first impulse, here's the second. So now we can then say, when does this equal 0? It's at 3/2. So this impulse is sitting at 3/2 where it actually occurs. And the second input happens at tau equal to 1/2. What that is saying is that second impulse has now worked its way up to 1/2 of a second. It's already initiated its response, and here's the part it's exciting right now. All right. So now you multiply the impulse response times all the inputs, and you add up what you get. Okay, this is an impulse. The sifting function, when you integrate them, you multiply them together, you integrate it, you get the value of the function at that time. It's a 1. This has do the same thing here. You get a 1 times 2, so there's 2. 1 plus 2 equals 3. At time equal to 5/2, so we're going to take ourselves out to here. We predict the answer is 2. All right, so here we have 0 to 2. We show the impulse response. At 2.5 seconds, the first impulse has worked its way all the way through the impulse response. It's left a 1/2 second ago, so it's not exciting anything. Its output is 0. The output of this double intensity impulse, okay, you have 2 times 1, 2. There you go. And then, of course, if you go at 3.5 seconds, which is out here, you would have none of, I don't have a picture for that, but picture if this slides out to here and then the other one moves up. If you have no inputs inside of the impulse response, when you multiply them together in the integral, okay, which is right here, you get nothing. So if I of tau, t minus tau times s of tau produces 0 everywhere with tau, the integral is 0. So there's our next example. And we're going to do a bunch more of these. Here's the next one that's coming up. Take a break. When you're ready, come on back.